Hello everyone, our lesson today is lesson 1 in unit 5, which is central angles and measuring arcs. Central angle. First, the definition of the central angle. Any angle consists of vertex and two sides. So the central angle, from its name, its vertex is the center of the circle and its two sides will be two radii. So the central angle, its vertex is the center of the circle here, and two sides will be two radii. So measure BMA is an central angle. Okay, so here we have angle BMA is a central angle. The measure of the central angle equals the measure of the subtended arc. So here we have the arc AB. If the measure of the arc AB is 80 degrees, so the measure of the central angle BMA also will be 80 degrees. So here we have the measure of the central angle BMA equals the measure of the subtended arc. Okay, we have here the minor arc, which is AB, and the major arc, which is BCA. Of course, the major arc, its measure is greater than the minor arc. We have also the measure of the circle. Here the measure of any circle is 360 degrees. Okay, so we studied the central angle. The central angle, it's an angle, its vertex is the center of the circle, and the two sides contains two radii. And we know the measure of the central angle equals the measure of the arc, and the measure of the arc equals the measure of the central angle. Here the length of the arc. The length of the arc equals the measure of the arc over the measure of the circle, as we said, 360 degrees times circumference of the circle, which is 2 pi r. So we know the measure of the arc and the length of the arc. The measure of the arc equals the measure of the central angle subtended by the same arc, and the length of the arc equals the measure of the arc divided measure of circle times circumference, which is 2 pi r. We have an example number 1. If measure of arc AB equals 60 degrees and the radius is 7 centimeter, find the length of the arc AB. So direct substitution in the law. Here the length of the arc AB equals the measure of the arc divided the measure of the circle times circumference. Substitution. Here the measure of the arc is 60 degrees divided, as we said, the measure of any circle is 360 degrees times circumference 2 pi r. 2 multiplied by 22 over 7 times r here is 7. Using your calculator, the result will be 22 over 3 centimeter, because we talk about the length. Okay, another example. Here in the opposite figure we have two radii, MA and MB, and the measure of the central angle here AMB is 90 degrees. So of course the subtended arc here BA also equals 90 degrees. Okay, here measure of angle A is 45, and MA, which is radius, is 7 centimeter. So of course here MB also 7 centimeter, because they are two radii. Here MA equals MB, so the triangle AMB is an isosceles triangle. So the two base angles equals in measure. So measure of angle BAM equals measure of angle MBA, which is 45 degrees. We want to get the length of AB. Here we want to get the length of AB. The length of AB equals what? Equals the measure of the arc divided measure of circle times 2 by r. So we want to get the measure of arc. As we said, the measure of arc equal the measure of the central angle subtended by the same arc. Okay, so here the proof. First, since MA equals MB, y 2 radii. So we get measure of angle A equals measure of angle B equals 45 degree. Here the sum of interior angles of the triangle AMB is 180. So to get measure of angle AMB equals 180 degree minus 45 degree plus 45 degree, it will be 90 degree. Okay, so here measure of angle AMB equals the measure of the arc AB, which is 90 degree. Substitution. So the length of AB equals the measure of the arc over the measure of the circle times circumference, which is 2 by r. Substitution. The measure of the arc 90 degree over 360 degree times 2 by 22 over 7 and the radius 7. Using your calculator, the length of the arc AB will be 11 centimeter. We have some corollaries. Number 1. Here, the measure of the arc AB equals the measure of the arc CD. So we get the length of the chord AB equals the length of the arc AB equals the length of the arc CD. So here, if measure of arc AB equals measure of arc CD, so they are equal in length. So the length of the arc AB equals the length of the arc CD. The second one, and vice versa. If we get the length of the arcs are equal, so the measure of these arcs are equal. The second one, here we have the measure of the arc AB equals the measure of the arc CD. So its chord here are equal in length. So here, if measure of arc AB equals measure of arc CD, so we get here the two chords are equals. So in the first we have if the two arcs are equal in measure, so they are equal in length. Also, if they are equal in measure, the two chords are equal in length. Number 3, and also vice versa. Number 3, if AB parallel to CD, we get here the measure of arc AC equals the measure of arc BD. So we get the measure of arc AC equals the measure of arc BD. The third one here, if CD touches the circle, as we said in the previous unit, CD touches the circle, so CD here is called tangent. So here we have tangent CD parallel to AB. AB parallel to CD, and CD is a tangent. We get also the measure of the two arcs AC and BC are equal in measure. The measure of arc AC equals the measure of arc BD. We have an example. Number 1. CD is a tangent. AB parallel to EF parallel to CD. As we said in the proof, any given we get from any given, in the example we get the result. First we take AB parallel to EF. Since AB parallel to EF, so the measure of the arc BE equals the measure of the arc AF. Okay, so we write first, since AB parallel to EF, we get the measure of the arc, measure of arc BE equals measure of arc AF, and let it number 1. Also here we have EF parallel to CD, so the measure of arc EC equals the measure of arc FC. So here since EF parallel to CD, we get measure of arc EC equals measure of arc FC, and let it number 2. He wants to prove that BC equals AC. BC equals AC. So, by adding arc BE to EC, we get the arc BC. So by adding 1 and 2, 1 and 2, we get the measure of arc BC equals the measure of arc AC. So here we have two arcs are equal in measure, so the two chords are equal in length, so we get BC equals AC. Okay, thank you.